Okay, so when we started working on sequences a couple of classes ago, we were dealing with what we call explicit rules. So explicit rules are rules that we can write for any term. So we were finding it for the nth term. Today what we're going to do is learn how to find what's called a recursive rule. And recursive rule is only to let you find the next term in the sequence. So let's look at the two kinds of sequences that we've been working with in the past. We've been working with the arithmetic sequences and working with the geometric sequences. As a review, the arithmetic sequences are the ones that we can add or subtract to. So they're the ones that have a common difference that we either add or subtract. So when we look at the rule, at first you look at the rule and it looks like, ooh, that's a little bit scary. But all it's saying is we're taking the term before plus our common difference, so plus whatever we're adding or subtracting. And then when we look at the geometric recursive rule, in geometric sequences, that's the one where we're always multiplying times the common ratio. So when we look at the rule, we're just taking the ratio and multiplying it times the term right before that. So if you kind of think about it, in an arithmetic sequence, we know that it's going to be plus a number. So let's just say, for example, plus 5. If you've got an x, where do you normally put plus 5? Well, we would put it behind it. So x plus 5, and that's really the way they're writing the recursive formula. If we have an x and we want to multiply it times 5, normally we put the 5 in front, 5x. That's just the way we write it in algebra. So if you look at the recursive rule, that's why they're putting the ratio and then the number before it. So it makes sense the way they've written it. As soon as you get past seeing the a sub n and all the scary numbers and letters, it really makes perfect sense. So let's look at practice number 1. First, I'm going to make this a little bigger. First thing we look at is they've given us this little a with a sub 1 beside it. Remember, that's just saying the first term. So first term is all that a sub 1 means. So my first term is 2, so I'm going to go ahead and put a 2. And then they've given us the recursive formula. Now in this formula, it's either going to be multiplying if it's geometric or adding if it's arithmetic. Well, I can already see that this is 7 times the term before. So this one is a geometric sequence. So I'm just going to put in my formula and say a sub 2 is going to be 7 times a sub 1, which is 2, equals 14. So what it's asked us to do is say, hey, we know this one is geometric, and they've given us an r, and our r is 7. Okay, let's look at example number 2. So on example number 2, we need to decide if this equation right here is arithmetic or geometric. That's pretty easy to see that we're adding something. So it's going to be arithmetic, and we're actually adding 1. So there's no geometric. We can cross that out. Now, if we wanted to actually write the next number in the sequence, we've been given our first term in the sequence is 18. And if we want to get our second term in the sequence, we would say a sub 2, that would be our second term, equals a sub 2 minus 1 is 1, so the term before, which is 18, so equals 18 plus 1. So our second term in the sequence is 19. That's all there is to working with this rule. Okay, so let's go ahead and move on to practice. And practice is giving us the first term of the sequence, giving us the recursive formula, and asking us to write the next 3 terms of the sequence. So looking at number 3, if I look at my formula here, I have to decide, is this going to be arithmetic or is it geometric? Well, I'm not adding things to the end, I'm multiplying at the beginning. So I know I've got a geometric sequence. My first term, a sub 1, equals negative 2. So if I want to find my second term, I want to find a sub 2, that's my second term. It's going to be, I'm going to use this right here, my negative 2 times, and then I'm times it, a sub n minus 1. So I'm timesing it by the term before. So negative 2 times negative 2 equals positive 4. So my a sub 2 is going to be positive 4. Okay, so now that's only the first 3 terms, that's only the second term. So now we need to do it for a sub 3. So a sub 3 means our third term. Again, we're taking the negative 2 from our ratio, negative 2 times the term before. Well, our term before now is 4. So times 4 equals negative 8. So now we've written the first 3 terms. They are negative 2, comma 4, comma negative 8. Those are the first 3 terms in the sequence. Okay, let's try it again with number 4. Okay, so number 4, when I'm looking at my recursive formula, I can see that I'm adding 3 here at the end. So I know it's an arithmetic formula. I'm adding 3 to the term before. So my first term equals negative 4. Now I want to write my second term. So I take the term before, which is that one, negative 4, plus, and then from here, plus 3. So negative 4 plus 3 equals negative 1. So my second term, a sub 2, equals negative 1. Now let's do a sub 3. So again, I have to take the term before. So I'm going to take this negative 1 plus, and again, I'm taking what we're adding to it. So negative 1 plus 3 is positive 2. So my sequence, my first term is negative 4, my second term is negative 1, my third term is 2. And if I look at this, this makes pretty good sense because I was told that my arithmetic sequence is adding 3 each time. So negative 4 to negative 1, I added 3. Negative 1 to 2, I added 3. So I've just followed the pattern. Okay, so let's go ahead and turn the page. Okay, so now they've given us a couple of sequences and they want us to rewrite the recursive rule for it. So to write the recursive rule, first we need to decide, is it arithmetic or is it geometric? So when I look at this first one, and let's make it a little bigger. When I look at number 5, I can already see it's not subtracting the same number. So it's not going to be arithmetic, it's going to be geometric. And to get from here to here, and from here to here, from here to here, it looks like we're multiplying, so our R equals 1/3. So we're multiplying it times 1/3. So then all I have to do is write the recursive rule. And our recursive rule for geometric is going to be a sub n. So the term is going to be R, which is 1/3, times a sub n minus 1. So it's just basically saying multiplying our ratio times the term before the one we want to find out. Okay, so now let's look at number 6. And when I look at number 6, I can already see that I'm adding 5 every time. So I know that this is an arithmetic sequence, and my common difference equals positive 5. So in order to write my recursive rule, I'm going to say a sub n equals the term before, so a sub n minus 1 plus our common difference of 5. So it's really just doing what you already know it's doing, but putting it into a formal rule. Okay, so let's look at number 7. Okay, so on number 7, again, they've given us what looks to be a geometric sequence. And so to see what we're multiplying by, I'm going to just take this term here, 25, and I'm going to divide it by the term right before it, 125. And that tells me that I have a common ratio of 0.2. So I'm going to go ahead and say common ratio equals 0.2. Now that I know that, I can go ahead and put it into the formal recursive equation. So I'm going to say a sub n equals our common ratio, 0.2, times a sub n minus 1. And that's our formal rule. Okay, let's look at number 8. Okay, number 8, like I always say when we have it in a graph, let's go ahead and put these numbers in a table so we can see the pattern. So I'm going to just start by writing my XY table. And I've got 115, 212, 39, 46, and 53. Okay, so if I look at this, looks like I'm minusing 3, and if I take it on down, it's happening that way every time. So this is an arithmetic table. It's got a common difference of minus 3. So to formalize this, I'm going to say a sub n equals the term before, a sub n minus 1 minus our common difference, so minus 3. And that's the answer to it. Okay, so let's go ahead and move on over to number 9. And in number 9, they want us to write an explicit rule for the recursive rule. So translating that, they want us to write a rule that can work for any term, and what they've given us is a rule only for the term before. So they've given us the rules that we learned today, and they want us to write it in a more general rule. Okay, so to write, first thing we have to know, is this arithmetic or geometric? Well, we can see that it's geometric because right here we have our R, our common ratio, being multiplied. So if it's being multiplied, we know we've got a geometric sequence. So let's just write out the two things we know. For geometric, we need to know our first term, which is 4, and we need to know our ratio, which is 3. And then to write this as an explicit rule, we're going to say a sub n, we don't know what n is, equals our first term times our ratio raised to the power of n minus 1. That's what we were doing in class yesterday. Okay, let's look at the next one. Okay, now on number 10, they've given us a recursive rule that's adding 11. So we already know that this is an arithmetic table. So let's write down an arithmetic table. All we really ever learned to do on this was stat edit. So that's what we're going to do. So we know that we have a sub 1 equals 6. So I'm going to go ahead and start me a table over here, xy. My first term equals 6. And then I'm adding 11 to it. So 6 plus 11 equals 17. So my second term is 17. 17 plus 11 is 28. My third term is 28. Now I have 3 terms. I can go ahead and put it in stat edit. This is arithmetic, so I know it's a linear table, so I can do stat edit, stat calculate 4, and get my equation. So I'm going to pause the video. Everybody get your equation, then start it back up. Okay, so I come up with y equals 11x minus 5. Let's make sure this makes sense. We know that our table is changing by 11 each time. So our slope, our rate of change, is 11. That's what goes with the x. And then our starting point, which we can't see, if we went back 11 here, we would take us to -5. So yep, the rule that we wrote makes perfect sense. Okay, let's move to number 11. And number 11 wants us to write the recursive rule, so the one that just gives us the next term, so recursive rule, and they've given us the explicit rule. So if we look at number 11, we know we're dealing with arithmetic. That is your basic slope-intercept form equation. As we just saw in number 10, our slope, the number next to the variable, that's what we're changing by every time. So our common difference for this table would be the 6. So to do this, all we have to do is our a sub n equals the term before, so a sub n minus 1 plus the common difference. And now we've written our recursive rule for the explicit rule. Okay, let's look at number 12. And number 12, we need to write the recursive rule. They've given us the explicit rule, and obviously this one's being multiplied, so it's a geometric sequence. So all we have to do on here is be able to identify our common ratio. And our common ratio is the number in parentheses raised to the power n minus 1. So we know that our ratio equals -3. So to write the recursive rule for this, we're going to say a sub n equals our ratio, which is, I'm going to go ahead and put it back in parentheses, is -3 times our a sub n minus 1. So times the term before. Okay, that's all we have for the notes. I'm going to go ahead and take you through a couple of the classwork ones just to make sure that you are able to see an example of each one. So turn the page to your classwork. Okay, so this first section wants us to write the first 6 terms of the sequence. This is just like number 3 and 4 on the front of your notes. And so I'm going to go ahead and do number 3 with you. So I'm going to make it bigger. Okay, so on number 3, I need to write the first 6 terms of the sequence. I already know that my first term is 4. So my first term is 4, and I know that I'm going to use a common ratio of 2 multiplied by the term before it. So if I start a table, maybe it's easy to start a table on this of xy, I know that my first one is 4. So I got to do 2, 3, 4, 5, 6. I got to do 6 of them. Every time I'm going to be multiplying the term before, so this one will get multiplied times 2 to get that one. So 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So the recursive rule just showed me how to get it started, and I just followed it from there. Okay, let's go ahead and look at group 5, 6, 7, and 8. So this next little section, this one wants us to write a recursive rule for the sequence. So it's wanting us to first decide if it's an arithmetic or a geometric, and then write the rule that goes with it. So let's go ahead and just do one of these. Let's do number 8, I think. Yeah, let's do number 8. Okay, so number 8, when I'm looking at this, first thing I have to decide, is this arithmetic or geometric? So when I'm looking to go from 9 to negative 18, I'm going to multiply times negative 2. And just check and see, and that works every time. So I know that my common ratio is negative 2. So if I want to write my recursive rule, I just say a sub n equals, and the recursive rule, ratio is going to come first. So I'm going to put the negative 2 first times a sub n minus 1. So just the ratio times the term before. That's all it says. And then we get to number 9 and 10, write an explicit rule for the recursive rule. And if you look back on your notes, it's exactly like 9 and 10 on the back of your notes. So I'm not going to do another one of those. It's the exact same process. And then when we look at 11 and 12, they're exactly like 11 and 12 on your notes. So again, I'm not going to do another example. Go ahead and finish your classwork and get ready to take your test.